For over half a century, one name has ruled the skies at the edge of space and speed: Blackbird. The SR-71, a titanium ghost that flew so high and so fast, no enemy missile could catch it. But now, a new shadow is emerging: the SR-72 Darkstar, a hypersonic spy plane designed to dominate the skies of tomorrow. Two aircraft, one legacy, but vastly different worlds of technology. Today, we are diving deep into the performance, flight dynamics, and engineering evolution of the SR-71 and SR-72. From Mach 3 to Mach 6, from Cold War secrets to AI-powered hypersonic dominance. This isn't just a comparison. It's a journey through the future of aerial reconnaissance. Let's begin. Chapter 1: The Legend, SR-71 Blackbird. The Lockheed SR-71 Blackbird wasn't just a plan. It was a statement developed in the 1960s by Kelly Johnson and his legendary Skunk Works teams. It was built to fly higher and faster than any aircraft before it, to outrun threats, no fight dams. Max speed Mach 3.3, over 2,200 miles per hour. Service sailing over 85,000 feet. Range 3,200 miles. Engine twin Pratt Whitney J58 turbo-ramjets, a hybrid system unlike anything before. Now here's what made the J58 so special. At subsonic speeds, it worked like a normal turbojet, but once the SR-71 passed Mach 2.4, the engine's bypass system redirected air around the turbine, feeding it directly into the afterburner, essentially turning it into a ramjet. This allowed sustained flight at Mach 3+, where most jets would overheat and fail. But flying this fast created extreme challenges. At Mach 3, skin temperatures reached 600 Fahrenheit, hot enough to melt aluminum. So the SR-71 was built from 93% titanium, a metal so difficult to work with. Lockheed had to secretly buy it from the Soviet Union during the Cold War, using third-party companies to avoid suspicion. And here's a wild fact: the SR-71 leaked fuel on the ground. Its fuel tanks weren't sealed because at temperature the titanium expanded and sealed the gaps. So it literally had to refuel immediately after takeoff. Otherwise, it would lose thousands of pounds of JP7 fuel before even reaching cruise. And the cockpit. Imagine flying at 85,000 feet, where the sky is black and the curvature of the earth is visible. But your canopy gets so hot, it glows red. Pilots wore pressure suits like astronauts. not just for altitude, but for survival. Yet, despite all this, the SR-71 was never shut down. Over 3,500 mission, zero losses. Enemy radar could see it, but by the time missiles launched, the Blackbird was already 100 miles away. It wasn't stealthy by today's standards. It had a massive radar cross section, but it didn't need a stealth. It had a speed as its shield. Chapter 2: The Future, SR-72 Darkstar. Fast forward to 2013. Lockheed Martin quickly unveiled a new concept, the SR-72, a successor to the Blackbird, but not just faster. This time hypersonic, designed to fly at Mach 6, over 4,500 miles per hour. The SR-72 aims to cross continents in under an hour, from New York to Moscow, less than 60 minutes. But how? The secret lies in its combined cycle propulsion system, a turbojet plus scramjet hybrid. Here's how it works. From takeoff to Mach 3, a conventional turbojet engine powered the aircraft. Then, at high speed, the scramjet, supersonic combustion ramjet, takes over. Unlike traditional ramjet, a scramjet allows air to flow through at supersonic speed, enabling combustion at Mach 5 and beyond. No other operational aircraft can do this, and it's one of the hardest engineering challenges in aerospace. But hypersonic flight brings new nightmares. At Mach 6, air friction hits the airframe to over 3,000 Fahrenheit, hotter than lava. So the SR-72 can't use titanium like SR-71. Instead, it relies on advanced ceramic matrix composites and carbon-carbon materials. Materials that won't melt, warp, or lose strength. And aerodynamically, hypersonic flight change everything. Shock waves, plasma formation, boundary layer instability, even a 1-degree change in angle of attack can cause catastrophic loss of control. So the SR-72 won't just need powerful engines. It will need AI-powered flight control system, real-time sensor fusion, and adaptive surfaces to maintain stability. It's not just a plan, it's a flying supercomputer. Chapter 3: Performance Comparison, SR-71 vs SR-72. Let's break down the numbers. Max speed, SR-71 Mach 3.3 and SR-72 Mach 6 plus. Altitude, SR-71 85,000 feet, SR-72 100,000 feet. Propulsion, SR-71 Blackbird turbo-ramjets, SR-72 Darkstar turbojet scramjets hybrid. Flight regime, SR-71 Blackbird supersonic, SR-72 Darkstar Hypersonic. Radar cross-section: SR-71 large, SR-72 low observable, stealth design. Materials: SR-71 titanium, SR-72 ceramic, advanced composite. SR-72 isn't just faster, it's smarter, stealthier, and more survivable in modern aerospace. Today's air defenses, like Russia's S-400 and S-500 or Chinese HQ-19, can track and engage high-altitude, high-speed targets. The SR-71, while fast, would be vulnerable today. But the SR-72, at Mach 6, even the fastest surface-to-air missiles can't intercept it. And with stealth shaping and radar-absorbing materials, it may not even be seen until it's too late. Chapter 4: Flight Dynamics, Supersonic vs Hypersonic. Now let's talk about flight dynamics. How these planes actually fly. As the SR-71 operate in the high supersonic regime. Its delta wing and chained fuselage help manage shock waves and reduce drag. Control surfaces were large and effective, but the plane was still difficult to handle at low speeds. Landing an SR-71 was like balancing a pencil on your finger, unstable, demanding, and unforgiving. But SR-72 operates in the hypersonic flight regime, where physics gets weird. At Mach 6, air doesn't flow smoothly, it's ionized, forming plasma. Traditional control surfaces become ineffective. Aerodynamic heating warped surface in real time. GPS and radio signals can be disrupted by plasma shield. So, how do you control it? Engineers are testing morphing wings, thrust vectorings, and even plasma actuators, devices that manipulate airflow using electromagnetic fields. And navigation. It likely use inertia navigation system (INS) fused with AI. Because relying on GPS at Mach 6 is like trying to read a book while riding a bullet. The SR-72 won't just fly. It will think, adapt, and react mid-flight. Chapter 5: Why the SR-72 matters, the future of reconnaissance. In today's world, satellites provide most intelligence, but they were predictable, they follow orbits, and they can be jammed, blinded, or destroyed in conflict. And SR-72, however, can be launched on demand, fly unpredictable routes, collect real-time data, and return, all before an enemy can respond. It could monitor missile launches in real time, track hypersonic weapon tests, conduct electronic warfare, even launch small drones or missiles. And with AI, it could analyze data mid-flight, decide what's important, and transmit only critical, reducing the risk of detection. Some experts believe the SR-72 could be first operational hypersonic aircraft in history, ushering in a new era of promised global strike and reconnaissance. Chapter 6: challenges, and status. Despite the hype, the SR-72 is not yet confirmed to be flying. Lockheed Martin has conducted scramjet tests and wind tunnel experiments. And in 2022, they said a demonstrator could fly by the early 2030s. But the challenges are massive. Scramjet reliability at Mach 5 plus, thermal management at extreme temperatures, materials that survive repeated hypersonic flights, cost likely over 1 billion per unit. And of course, politics. A hypersonic spy plan could escalate tensions, flying over hostile nations in minutes. But the US isn't alone. China and Russia are testing their own hypersonic vehicles. The race isn't just about speed, it's about strategic dominance. Final thoughts. The SR-71 was a triumph of Cold War engineering, machine that pushed the limits of what was possible with 1960s tech. The SR-72, it's a vision of the future where speed, stealth, and artificial intelligence converge, where a single aircraft can cross the globe in less time than it takes to watch this video. Will it fly? Almost certainly, but not tomorrow. The technology is coming together, but slowly. But when it does, the sky won't be the limit. It will be the highway. What do you think? Will the SR-72 redefine air superiority? Can anything stop a Mach 6 spy plan? And should we be worried about hypersonic weapons and surveillance? Let me know in the comments. If you enjoyed this deep dive into aerospace history and future of flight, smash that like button, subscribe, and hit the bell, because we are going even faster next time. Until then, keep looking up. The future is flying.